Hello everyone, in this TRC car tutorial number 49 we will speak about the team which was awarded by the Nobel Prize and the quick technology progress during the 10 years following the point contact transistor invention. Finally, we will do a summary of the electronic history since 1912 up to now. When the point contact transistor was invented, the Bell Lab feared that Purdue University might make a similar discovery, so a patent was quickly recorded for the invention of the point contact transistor by Bardeen and Brattain, but Shockley was not in the patent. Shockley believed and stated that he should have received all the credit for the discovery of the transistor. He actively excluded Bardeen and Brattain from new areas of research. Brattain was transferred to another research group within Bell Lab. He continues to study the surface properties of solids and the transistor effect. John Bardeen describes it as an intolerable situation, and he decided to leave the Bell Lab to join the University of Illinois in 1951. So Bardeen started in 1945, did the point contact transistor 2 years later, and left the Bell Lab 4 years after the transistor invention. Shockley's theory on the bipolar junction transistor was an impressive achievement, pointing the way to future solid-state electronics. Just after the point contact transistor invention, in the middle of December, William Shockley began an intensive month of theoretical activity, and just 1 month later, the January 23, 1948, he invented a different transistor based on the PN junction. John Bardeen, 21 years after leaving the Bell Lab in 1972, was awarded by a second Nobel Prize for the theory of the superconductor. He became the first person to win 2 Nobel Prizes in the same field of physics. Somehow, he worked on semiconductor, almost an insulator for an intrinsic semiconductor, and superconductor with zero resistance. Only 5 others have received more than 1 Nobel Prize, as for example Marie Curie, with 1 in physics and 1 in chemical field. Shockley's parents was from California. Since his mother was elderly and alone, he decided to return to Palo Alto to start its own business. He brought to his company, the Shockley Semiconductor Lab, talented engineers and scientists. One of them was Robert Noyce, the future co-founder of Intel. But Shockley was a very difficult person to work with. Noyce left the company 1 year later, having issue with the Shockley management style. According to Stephen Fairchild, Noyce's passionate presentation of his vision of the future of electronics was a reason why Fairchild had agreed to create the Fairchild semiconductor. 7 other persons left the company with Noyce, called the Traitorous Eight by Shockley, joined the Fairchild Semiconductor Company in 1957. Somehow, Shockley was able to find the very good, talented people, but was not able to work with. Almost 10 years later, in 1968, Noyce and Moore were created Intel. The Shockley Semiconductor Lab, after the Traitorous Eight left, was going down. Shockley believed a lot to the new NPNP component structure to build a switch as the Silicon Controlled Rectifier, SCR, with a single component to do a switch. But just few years later, the integrated circuit will do much better by doing a complete circuit, and the SCR was mainly used in the power component domain. Brattain retired from Bell Lab in 1967, moved back to Washington and taught at Whitman College. He died of Alzheimer's disease in 19 1987 at 85 years old. William Shockley died in 1989 at 79 years old. And the double Nobel Prize John Bardeen died in 1991 at 83 years old from cardiac problem. The point contact transistor worked in the Bell Lab for the first time the December 16, 1947. This new point contact transistor was presented to the Bell Labs 2 days before Christmas, the 23rd December 1947. As we already said, the point contact transistor had plenty of issues and was quickly replaced. But its main interest was the demonstration that for the first time, amplification with a solid-state electronic was feasible. The simple fact that this little component worked has started a tremendous wave of excitement. The William Shockley hard months of intense theoretical activity to develop the future bipolar junction transistor is a good example of this excitement. The first integrated circuit just 10 years after the point contact transistor invention is another example of the excitement produced by this first point contact transistor achievement. The June 30, 1948, the point contact transistor was presented in a press conference. The press release was done in July 1st, but almost nobody in the large public remarked this small article describing the transistor invention. Here is an interesting story not too much known, I think. During the Second World War, Herbert Matare, a German physicist, was working on the duodiode for low-noise radar mixer stages in the Telefunken company. His experimental duodiodes had similar geometry to a point-contact transistor, two-point contact on a single germanium block positioned closely to one another. He noticed that the second contact has a special behavior and it was not working as two independent diodes. But at the end of the Second World War, the Telefunken laboratory was bombing, so they need to relocate very often, so this situation was not favorable to analyze and do studies. After the war, Herbert Matare and Heinrich Welker, both German scientists, was employed by Westinghouse in France to continue the development of the point contact transistor. Heinrich Welker was a specialist of the germanium crystal and it worked to purify the germanium crystal. Herbert Matare and Heinrich Welker, both German scientists, developed in parallel and independently the point contact transistor and applied for a patent in 1948. Both devices, the Bell Lab 1 and the Westinghouse, were point contact types independently developed. In the Thierry Secker tutorial number 37, we noticed that the triode was invented in parallel by De Forest and von Lieben, with both patented the same year, 1906, with 7 months differences. In the case of the point contact transistor, it is almost the same story with less than 1 year between both independent inventions. The called French transistor was presented to the public the May 18, 1949. Bell Labs announced the Shockley bipolar junction transistor on July 4, 1951. The theoretical study of the bipolar junction transistor was done in January 1948, but they need 4 years to build the first working bipolar junction transistor. Even if the point contact transistor was almost invented in the same time on both sides of the Atlantic, the Bell Lab would have been victorious anyway with the development of the PN junction and the bipolar junction transistor. In January 1954, Bell Labs fashioned the first silicon transistor using a Gauss junction technique. But the labs did not pursue the silicon process further, thinking it is unattractive for commercial production, which allowed Texas Instruments to claim credit for this breakthrough several months later. In 1955, the Bell Labs announced the MESA transistor topology. Starting from a light n-doped used for the collector, they build a P-base by an epitaxial growing, then the N-plus emitter was diffused in the P-base. Of course, the base collector junction was not passivated, this could create some leakage, but even with this drawback, this process was a great improvement in the bipolar transistor fabrication. A little bit less than 4 years after the MESA transistor, in September 1958, the first integrated circuit was demonstrated by Texas Instruments, done by Jack Kilby. We have to realize that this is just 10 years after the Shockley theoretical bipolar junction transistor study. A few months later, after the first integrated circuit in early 1959, another key milestone was reached with the development of the planar transistor by the new company Fairchild Semiconductor. In a light-doped N- silicon substrate used for the collector, a first P-diffusion was done to change the initial P-doping in P-doped. Then a second N+ doping to change again the P-base doping in N+ doping. The advantage compared to the MESA process is that all PN junctions are passivated with a silicon oxide. Of course, to work this topology needs to almost multiply by 10 the doping concentration at each doping change. This double diffused planar process will allow to do a mass-produced monolithic integrated circuit possible. 6 months after Kilby, Robert Noyce at Fairchild Semiconductor developed a new variety of integrated circuit more practical than Kilby's implementation. Noyce's design was made of silicon instead of germanium. The PN junction isolation was a key concept behind the integrated circuit. This PN junction bias in reverse was doing the isolation, allowing each transistor to operate independently despite being parts of the same piece of silicon. We have to realize that the point contact transistor was a trigger for an incredible 10 years of solid-state electronic development. In this slide, I try to concentrate the main invention in the electronic domain from 1912 to 2018. This date, 2018, came from the fact that this slide was initially done for the 70 years anniversary of the transistor. In 1912, the triode was used for the first time to build an amplifier just before the First World War. 35 years later, the Bell Labs invented the first point contact transistor able to do an amplification with a solid-state electronic just after the Second World War. On the picture with Bardeen, Breitain and Shockley, you can note on the left a part of a pretty big oscilloscope, built of course with vacuum tubes. The Regency DR1 transistor pocket radio was using 4 point contact transistors. It was the first popular usage which popularized the name of transistor. People were saying only transistor instead of a transistor pocket radio. 1958 was the birth date of the integrated circuit, just 11 years after the point contact transistor invention. Then, 1 year later, in 1959, finally the Bell Labs did the first metal oxide silicon MOSFET, this first MOS using the metal for the gate, and had some issue because the metal gate needs to overlap the drain and source due to the mask alignment accuracy. Then, 9 years later, in 1968, Fairchild Semiconductor did the first self-aligned poly-gate oxide silicon. This was a huge improvement for the MOSFET development because the parasitic capacitance between drain and gate was minimum. I think in 1968, Noyce, which was working in Fairchild Semiconductor, sees the huge potential of this new MOSFET using the self-aligned polysilicon for the gate and created with Gordon Moore Intel in 1968. 6 years later, in 1974, the Intel 4040 was the first 4-bit microcontroller including 3000 self-aligned MOSFET with a 10 micrometer process. The same year, Motorola presented the 6800, an 8-bit microcontroller including 4100 self-aligned MOSFET. In 1916, 42 years later, the Snapdragon of Qualcomm had 3 billion of transistors with a 10 nanometer process. So the process was reduced by a factor of 1000 and the number of components increased by 1 million, which means 1000 by 1000 because the shrink is done on both directions X and Y. If we are looking at the silicon crystal size, the interatomic distance is in the order of 0.2 nanometer. If we compare with the 10 microprocess of the Intel 4040, the 10 micrometer is 50,000 times more than the interatomic distance. But now, if we compare with the 10 nanometer process of the Snapdragon, 10 nanometer is just 50 interatomic distances. In the future, it will be only 25 with a 5 nanometer process. This presentation was done initially the June 21st, 2018, so 70 years minus 9 days after the transistor press release date. It was also the occasion to get the 60 years anniversary of the integrated circuit, which is born in 1958 as the owner of the Thierry Sécart tutorial YouTube channel. On this picture, we have a little bit more of 1 century of electronics. It is a huge achievement from the vacuum tube and galena up to the 3 nanometer component size today and their billion of components. This video will clôture the electronic history started with the diode invention done in 1904. I want to thank you for your attention. On my next Thierry Sécart tutorial number 50, we will talk about the MKSI system and the new kilogram definition. So see you soon and stay tuned.